Hello students, today I am going to talk about conditional probability in this presentation. Let us start with a probability space. We are all by now familiar with the concept of probability space. Now given a probability space, let B be any event, that is B is an element of this collection of subsets. B be an event such that probability of B is positive. Okay, for any event, probability is a non-negative number, but we are taking an event that has a positive probability. Now for in event A, define P A given B. So we will read this as P A given B, or the conditional probability of A given B equal to a ratio So in the numerator I will take probability of A probability of A intersection B divided by probability of B. Please note this, that since P of B is in the denominator, therefore we require this probability of B to be positive. We can define conditional probability only when this conditioning event, B is called the conditioning event, has a positive probability. So we'll read this as the conditional probability of A given B. So that's how we'll read this statement. Now I make a statement over here. The function is a probability on the same space, same sample space and collection of events, meaning probability, meaning I will show that probability of A given B is, meaning it satisfies the three axioms. So what was axiom 1? That this is a non-negative number, and this is trivial. Why this is trivial? Because it is a ratio where the numerator and denominator are both probabilities. So this is a non-negative number. Now this is slightly not trivial. A given B. What do you think this is equal to? So if I go back to the definition, it will be probability of S intersection B. But B is an event, that means B is a subset of S. So what will be the numerator? S intersection B will be B. So probability of B by B is equal to 1. And third, now I take a sequence of disjoint events an, disjoint events. What do you think will be probability of the union, probability of this union given B, probability of an, union of an given B. So let me write here union script an n from 1. So I am taking the union over all the sets in this collection. So this is it, given B. What do you think this will be? So I am leaving this as an exercise for you. So here is the question mark. Now let me tell you that this will again satisfy the third axiom, that this will turn out to be sum of the conditional probabilities of an given B. But why that is so? So this is something I want you to figure out. Now you can also verify that conditional probability satisfies all the properties of probability. Now that's true because they as it satisfies the three axioms. We don't have to prove anything here. So we can straight away say what is probability of the null set. What is probability of the null set given B equal to, well, we can straight away say it is 0. Why? Because it satisfies the three axioms, and using the three axioms we have already proved that probability of any null set is 0. So conditional probability is also a probability, it will satisfy this. What will be probability of A complement given B equal to? So that I leave it for an exercise. So you can verify that it will satisfy conditional probability of the null set is 0, probability of A complement is 1 minus probability of A. Then if A and C are two disjoint sets, A union C given B, what will be this equal to? Where A and C are disjoint events. So in this way, if A is a subset of B, A is a subset of, let's say, D, then what will be the relation between probability of A given B and probability of D given B? So how these two conditional probabilities? Well, we, without doing any calculations at all, we can just blindly say this will be the exactly one and the same as we have seen for the ordinary probabilities, because all these results were obtained using the third axioms, and we have verified that the conditional probability satisfies the three axioms. So we can use all the properties of probability remain same for unconditional, same as for conditional probability. So I'll just end. However, probability, can you tell me what is this? B is this equal to 1 minus of is this true or false? This is or false. False. So this is something I want you to figure out. Thank you.